Hi, I'm Brian Heiston. I'm an Azure Sales Manager at Intel, and I'm here at Microsoft Build at the Intel Developer Reception. And I'm thrilled to be joined here today by Mark Russinovich, CTO of Microsoft Azure. So thanks again, Mark, for taking the time out of your day to spend with us.
Sure, thanks for inviting me.
Of course. So can you tell us a little bit about yourself and some of the work that your team is doing at Azure?
Well, so I'm CTO, as you mentioned, of Azure. I'm also the Deputy CISO for Azure. I've got a bunch of teams under me. One of them is a research team focused on confidential computing, actually, which is directly relevant to our discussion. Azure has got its roots basically building and scaling on top of Intel hardware. Intel is obviously a choice architecture for a lot of customers because they've got application compatibility where they're bringing the workloads from on-premises where they're running it on Intel hardware and want to run it in the cloud on Intel hardware. And Intel has done a fantastic job of both scaling up and scaling out for us in the cloud. So we've got their M-series virtual machines, the largest virtual machines on the planet on top of Intel hardware. Trust is a big term that covers a lot of things, like how our promises to customers about how we handle their data or don't view their data, how we keep their data resident where they want it to stay. But one part of trust is also protecting the data. And we've long had protection of data while it's at rest. In fact, when Azure started, it didn't have encryption of data at rest. And then we added service-side encryption and then customer managed key, bring your own key encryption on the network. 25 years ago, it was rare to have encrypted networking, and today people would look at you funny if you didn't have encrypted networking. And so the missing piece has been protecting the data while it's in use and creating a tight enclave around the data while it's in the clear. And so this is where confidential computing fits in. And so if we can host customer data inside of confidential computing enclaves, or they can host their own data in their own applications in those enclaves, they get this extra protection that the hardware is providing from all of the threats around it, whether it's the hypervisor, the hardware, the operators, anybody outside of that enclave does a great job of protecting. And this is part of building trust that their data is being handled the way they want it to be handled.
Yep.
Well, so we've been working for over a decade now, literally over a decade with you on getting confidential computing to the point where there's no compromise when it comes to performance. And so this has been a great collaboration where we've driven in requirements and you've done optimizations and we validated them together with benchmarks to get to the point now today where there's virtually no overhead at all. So no compromise when it comes to performance and running your confidential applications, whether including local access to local storage via NVMe from TDX, also lots of optimizations there to support those data intensive applications. We have talked about a spectrum of confidential computing and the promises that you get or the guarantees you get out of it. On one end, it's no confidential computing. The next click stop over, we call on confidential computing. And this is where you're going to get defense in depth and protection from the infrastructure and the operators of the infrastructure. And this is possible with just lifting and shifting your application into a confidential virtual machine. No changes to the application whatsoever. If you want to go a quick step further, that's where you go to confidential containers and you design the application to keep the data protected in the enclave or in enclaves throughout its entire lifecycle. That one also we're making easier with things like Azure Confidential Container Instances. And those also, of course, can run on Intel TDX hardware as well. And so you can pick your click stop for what guarantees you're looking for and how fast you want to take advantage of the platform.
Awesome. Well, thank you so much, Mark. It's really great to spend a little time with you and talk to you about Intel TDX.